Okay, so the last set of practice problems you had were numbers 8 to 11 on the forces problem sheet. So number 8 says a crate weighing 600 newtons. Okay, so weighing again, that means it's the FG, 600 newtons. Is being pushed across the floor at a speed of 5 meters per second. So there's some force here that's pushing it at a speed of 5 meters per second. If it's going at that speed, it means the AX is 0. It doesn't say it's speeding up to, it's saying at that speed by a horizontal force of 60 newtons. What is the coefficient of friction between the bottom of the crate and the floor? So acting up is Fn. Acting this way is friction. And this will be just m. And it wants to know what's mu. Okay, so you could find your m here because you have your Fg. I'm not going to because I want to show you something that's going to be a little bit cool. All right, so no forces at an angle, so we're just going to do sum of the forces in the y is equal to MAY, and this is not moving in the y. So Fn minus Fg equals 0. So Fn equals Fg equals 600 newtons. Okay? We can't go to FFR equals mu Fn right now because we don't have the mu. That's what we're solving for. So when you're solving for mu, your second step will be sum of the forces in the x is equal to MAX. And it said it was moving at a speed of 5 meters per second, which means it's not accelerating. So this goes to 0, which means the force you're pushing with minus friction must be 0. In other words, the force you're pushing with equals friction equals 60 newtons. So you have Fn and you have FFR. So FFR equals mu Fn. So mu is equal to friction over Fn. So friction is 60 newtons over Fn, which is 600 newtons. And look, you didn't need your m ever because the a's were 0, right? And so you'll end up with a mu of 0.1. What I mean when I say the a's are 0, because the a's were 0, the terms that had m by themselves canceled out, and so we didn't actually need to find the m. But you could have it. It would have been 61.16 something. Number 9. An object is being pushed across the floor with a force of 120 newtons parallel to the floor, so it's not a force at an angle. This F is 120 newtons. Coefficient of friction is 0.25. We have an Fg going down. We have an Fn going up. If there's friction, it's going backward. And it says the object accelerates, so we have our AX of 3.5475 meters per second squared, and it wants to know what is the mass, so they're not telling us the mass. But don't stress about that. That's okay. We can still find it. And if you don't know where to start, the answer always is sum of the forces in the y. So if you ever say, I don't know where to start, sum of the forces in the y. So sum of the forces in the y equals MAY. It's not moving in the y, so MAY is 0. So in the y, we have Fn going up, Fg going down, so it's minus equals 0. So Fn equals Fg equals mg, but you cannot find that this time. All you can do is leave it as mg. And then, if you want it, you could go to FFR is equal to mu Fn. And Fn is mg. So FFR is equal to mu mg. Now I suppose you could fill in your mu and you could fill in your g and you could multiply them, but don't. Why carry numbers when you could just carry mu mg, which is pretty, which is nice, and which doesn't need units? And we'll fill in our numbers in the end. So then you go to sum of the forces in the x. And in the x direction, you have F pulling one way and friction pulling the other is equal to MAX. And you're trying to solve for M. But do not just divide by A here, because there's an M hidden inside this FFR. This is really, so now we're going to sub for FFR. This is really F minus mu mg equals MAX. So you have two terms with M. Take this one over to the same side. So F equals MAX plus mu mg. And if you remember back when we were doing those two-part kinematic problems and we had two terms with delta t, we would factor the delta t out, do exactly the same thing here. Pull the m out and you'll be left with ax plus mu g, and now to get the m alone, divide both sides by the bracket. So ax plus mu g, and now fill your numbers in, and I'm just going to go over here to do that. So we have m is equal to, on the top, 120 newtons. On the bottom, 3.5475 meters per second squared, plus mu 0.25 g 9.81 meters per second squared. And when you do the math, you should get 20 kilograms. Okay? So don't stress if you don't have an M. It's either going to cancel out like it did in that one with the curling stone, or it's going to, you're going to solve for it. Either way, it'll be fine. Number 10. Number 10, a box weighing 500 newtons. So we're back to the weighing. That's the FG. So FG is equal to 500 newtons. And if there's an FG going down, there should be an FN going up. Weighing 500 newtons is being pulled along a level floor at a constant speed. Constant speed. AX is going to be 0. Constant speed. By a force of 50 newtons that acts upward at an angle of 30 degrees. So here's my F. It's 50 newtons. And it's acting upward at an angle of 30 degrees. This will be my Fy. This will be my Fx. It eventually asks for what is the coefficient. So there is friction, and friction will be acting backward. Okay, so in this one we've broken it up into steps for you to try to make it easier. So the first step is, what is the force that's actually pulling the box along the floor? In other words, it's asking you for what's the x component of this force, Fx. If you look at it, it's cosine. So it'll be cosine of 30 is equal to Fx over 50 newtons. So Fx is equal to 50 newtons times the cos of 30. Fx equals 0.866 divided by, so 43.301 newtons. That's the answer to part A. Part B says, what is the force of friction that opposes motion? So to find the force of friction, you have to do some of the forces in the x direction. So I know the question's taking you out of the order I was saying to do it in earlier, but it'll be okay. Because since AX is 0, this disappears. So it'll be Fx minus friction equals 0. So Fx equals friction equals the 43.301 newtons. Okay? C, what is the normal force? So now we need to go to the y direction. And you might want to find the Fy component here before you do that. The Fy component is the opposite side. So sine of 30 will equal Fy over 50 newtons. So Fy will equal 50 newtons sine of 30. So 25 newtons. And now go for part C. Sum of the forces in the y is equal to MAY. It's not moving in the y, so we have Fn, we have Fg, we have Fy. Fn is going up, Fg is going down, so it's a negative, and Fy is going up, it's a positive. Always solving for Fn in the y direction, so it'll be Fg minus Fy.